Hello, in this lesson we're going to review subnetting. So here we have our example. We have a local area network that has been using the network address of 192.168.100.0 with a subnet mask of 255.255.255.0. But you now have to create a new network that is going to require you to have 4 total local area networks. So we need to then take this address and break it down so that we can create 4 network and 4 network addresses and the related IPs that go along with them. The question is, how are we going to do that? We're going to do that through a process called borrowing bits. And we're going to take a closer look at that now. Let's review some basic information before we move forward into subnetting. We want to first determine exactly what part of this IP address belongs to the network and what belongs to the host. So to do that, what we're going to do is we're going to take these 2 values, convert them into binary, and we're going to do a process called ANDing. So let's take a look at the ANDing rules. 1 and 0 ANDed together are 0. Could be 0 and 1. 1 and 1 are ANDed together to 1, and 0 ANDed to 0 is 0. So this 192.168.100.0 address has been converted into binary here, and the subnet mask has also been converted to binary here. Notice the ANDing rules. The 1 and the 1 is a 1, a 0 and a 1 is a 0, a 0 and a 0 is a 0. So the net result of this address is actually going to be the top portion because the ANDed address is the same here. So whenever you AND with all 1s, it's going to eventually just become the value that you ANDed it with. So that means that our network address then is 192.168.100.0. And that is, right here, that is our ANDed address. That is what our network address is going to be. So now we know that this is our network address. Go back to the subnet mask. We're telling that in this equation that these bits are all turned on. You can see that right here with the 1s. That means these bits already belong to a network. There's nothing we can do about those bits. So in order for us to create new networks for these networks up here, what we're going to need to do is take bits out of the remaining part of the network or the host, which is this area right here or this area right here. And that is called borrowing. And that's what we're going to focus on next. All right, so we know that we're going to be working in this last octet. So what I've done here is I've made this last octet our focus, just those last 8 bits in binary. We have to think about this in binary because that's how the computer thinks about it. So what we're going to do now is we're going to figure out what happens every time we borrow a bit. So I'm going to come here and I'm going to bring up a little graphic. And it's going to be called Networks. And let's take a look at this. So in this graphic, we're going to say that n is going to be the number of bits borrowed, and that's going to be 2 to the n. So the formula reads, how many new networks do you have? Because you're going to be using the formula 2 to the n. So if we come back here and we say, let's borrow, let me change the color here. Let's borrow this bit here and make this a 1 instead, then this means the number of networks created is going to be 2 to the 1 because you borrowed 1 bit. And that means we are going to be creating 2 new networks. Well, that's great. I have 1 here and 1 here, but I need 4. So let's borrow another bit. Let's change this bit to a 1. And now the formula is going to read 2 to the 2. And that creates 4 networks, which meets my goal. 1, 2, 3, and 4. So what this tells us now is that my network bits are going to be 1 here, and they're going to be part of the 255s that were used here, and I'm only going to have left these bits right here for the host. Now, based upon the fact that we borrowed these 2 bits, what will our new subnet mask be? So we're going to basically come over here and we're going to place those borrowed bits into the subnet mask. So now instead of it being all zeros as we did before, it's going to be 1, 1, and the remainder are going to be zeros. So 0, 0, 0, 0, 0, and 0. Now what you're going to do is basic binary math. 1 times 128 is 128. 1 times 64 is 64, and then of course the remainder are all these going to be 0. You add this up, that equals 192. So our new subnet mask is going to be a little bit easier, and just put a little note in here. Our new subnet is going to be 255, 255, 255, 255 plus 192. And that is going to be what our new subnet mask is, and that allows us to have 4 networks. Now you may also see the subnet mask represented in something called CIDR, or classless internet domain routing. And that is when we see a representation with a slash and a number. That means this CIDR here is just how many bits are you using total in here for the subnet mask. So we know up here, this was our beginning, our 3 255s, and if you go back to your binary math, you know there's 8 bits, 8 bits, 8 bits, 8 bits. Well, these 8 bits are all turned on to 1. These are all turned on to 1. These are all turned on to 1. So this subnet mask in CIDR would have represented slash 24 because all these bits were turned on. This last octet, all those bits were turned off. So now our new subnet mask here is going to be 24 plus the 2 bits we just added here. And so now our new subnet mask in CIDR will be, come on back to this again, will now be slash 26 because the first 26 bits in this address are turned on. Our next focus will be on how many hosts did we get for each network, but for right now we figured out how many bits we needed to borrow in order to make 4 networks. Now that we've borrowed 2 bits away from the available hosts that we can make new networks out of, we have to look at what this leaves us per each of the new networks that were created. So we go back to binary and we look at the subnet mask, this last portion in binary. And these 2 bits are turned on. Those now belong to the network. We no longer can use them for any host addresses. But if you notice in purple, there are 6 left. And the formula for hosts is 2 to the h minus 2. Okay, so h is the number of bits that we're using for hosts. In this case, it will be 6. And then we have to subtract 2 from our total available number. We'll talk about that more in a second. So the formula for this particular equation would be 2 to the 6 minus 2. So that is 2 to the 6, if you do your math, that's 64, minus 2, and that equals a total available of 62 hosts for each of the 4 networks that we've just created. Now, let's go back. Why do we have to take away these 2? Well, we do that, go back here and look at this particular document for a minute. We do that because we have to reserve 2 hosts out of each list, one for the network address, one for the broadcast address. And what this looks like is the following. In binary, remember that's how we're thinking about this. This address up here, so let me come back, and I'm going to start with the black, and I'm going to say, all right, this address here of 1, 1, those are the network portions, and I'll use blue. 1, 2, 3, 4, 5, sorry about that, 6. I am not the best with this particular program, but that leaves us with these 6 bits right here. A host address where the entire host portion is 0 in binary represents the address for the network. And then let's change it up. If the host address is 1, 1, that's the network portion, and I'll use green, and we make these bits all turn on, so 1, 2, 3, 4, 5, 6, this portion right here is telling us that, draw a lock box around here, when all the host bits are set on, this is going to be used now for the broadcast address. All right, now let's take a closer look. Now, each of these bits in the network are going to be either on or off. The one here is just representing that they have been given to the network. So the first address that we had, if we come back to our 192.168.100. Now, what is the last dot? So what are our 2 network addresses? Well, let's take a look. In this particular, and let me grab some red here. In this particular octet in binary, we know those first 2 bits are belonging to the network. That's what's going to determine our network address. These bits are in binary, so that means they're either on or off. We said before that we are now creating a total of 4 networks. So those 4 networks are either going to be represented this way in binary, either as 0, 0, 0, 1, 1, 0, or 1, 1. Those are going to be our 4 networks. The network portion, again, is when all the host bits are 0. So 1, 2, 3, 4, 5. Squeeze another 0 in there, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yikes. And 1, 2, 3, 4, 5, 6. All right. So this is our 4 network addresses represented in binary. Again, it's network because these 2 here are representing the actual network portion, and then the entire host portion has to be in binary, a 0. So let's go back over here then. So our 4 network addresses that we just created are going to be .0. That's this one right here. The next one is going to be 192.168.100 dot, and then we have 0, 1. So we have to go back to binary math. In binary, this value is a 64. Everything else is off, so this is going to be 64. The next one, 192.168.100 dot. This one's on. These are all off. This value is 128. And the last network address is 192.168.100 dot. These 2 are turned on. That would be 192. So those are these addresses in binary. I can just move this over here. So we're looking at the same thing, just represented in decimal and how it represents in binary. Now, the second part of this is the host or the broadcast. So we said the broadcast address of a subnet, if you recall from TCP/IP, that is the address that is sent out to all hosts on a subnet. The broadcast address on a subnet is always represented by 1s in the host portion. So just like we did up here, we're going to do the same thing here. So we're going to come back here and we're going to go 0. Let me change this color. Make it a little bit easier for you to see. So we're going to go 0, 0, because the first network we already said was zeros, but now the remaining portions are going to be 1, 2, 3, 4, 5, 6. The next one is going to be 0, 1, 1, 2, 3, 4, 5, 6. The next person is going to be 1, 0. This one's going to be 1, 0. And the remaining bits are going to be 1, 2, 3, 4, 5, 6. And the last one is going to be 1, 1. And the remaining bits 1, 2, 3, 4, 5, 6. So let's convert this now over to decimal. We know that the network address is 0, so the remaining bits that we're going to add up are the values are going to be 1, 2, 4, 8, 16, and 32. So bring up our little notepad, and this case, the broadcast, I'll label this one, is going to be 192.168.100.63. Now where am I getting the 63 from? I'm getting it from here. This has a value of 1. This has a value of 2. This has a value of 4. This one has a value of 8. This one has a value of 16. And this one has a value of 32. And if I add 32 plus 16 plus 8 plus 4 plus 2 plus 1, that is going to equal 63. Because remember, in binary, each position has a positional value. We don't add these up because the value here is 64, 128, but when you multiply that by 0, they are 0. Okay, so let's go back and finish these out. So our next one is going to be 192.168.100.127. This time we're going to be adding in the 64. The next one will be 192.168.100.191 because now we're adding in the 128 to this number. And then the last one is going to be 192.168.100.255 because all the ones are turned on, so we would be adding 128 plus 64 to give us 255. So that is the broadcast, and these are the networks. So if I come back up here, and we can just label this. So that leaves us with one final piece. We know that the first network starts with 192.168.100.0 and it ends with 192.168.100.63. So what is left? What is the available scope that can be leased out or assigned with a static IP to each network address? And it's easy. It's just a difference from 1 to 63. So let's add one more note here, and we'll put it over here, and we'll say available scope. So the first one is going to be, and I'm just going to start at the 0. We can't, the last octet. We can't use the 0 address. So our available scope is going to be 1. Actually, I'll go ahead and do this first one out. .100.1 through 192.168.100.62. Because I cannot give out the 63, that's the broadcast. I can't use the 0, that's for the network. So the available scope then that I have is going to be from 1 to 62. Okay, let's do the next one together. So come back. And the next one is going to be, see right here, 192.168.100.65. So it's going to be 65 to, can't use the 127, so 126. The next one, I can't use 128, so it'll start at 129. And I can't use 191, so we'll end at 190. And the last one will start with 193, and we will end that at 254. So just proceed to 192, 168, 100 in front of each of these, and now you have the available scope for each network address. So to summarize what we've done in this example, we needed to create 4 networks. And to do that, we had to borrow from the subnet mask portion that showed us where our hosts were. We had to borrow bits from the available host to give us new networks. We have to do that because we can't just magically create new IP addresses. We have to work within the existing scope. So to do that, we borrowed 1 bit that created 2 new networks, because 2 values to the 1, a 0 or a 1, gave us just 2 networks. By borrowing 2 bits, that created us a 2 to the n, or 4 networks. Our 4 networks became these right here. Then we had to look at what portion was the host, which is all zeros. And then we add that here, and then we bring it over here, and then the 1s is the broadcast, and then what goes in between is the available scope. Now, just to make your life a lot easier, here's a little tip. If I go back to, let's try green. Actually, we'll try the green. If I go back here, notice that we only borrowed 2 bits. The last bit borrowed was the positional value of 64. Now look over here. See this number, this number, this number, this number? They have all incremented by values of 64. So I don't even have to do this or this to understand what my next network would be. 192, 168, 100.0, the next network automatically will increment by 64 bits. 64 bits, 64 bits. So that's just a little shortcut, and I'm going to go ahead and give you a new problem and have you try solving that, and then you pause the video and we will put up the answer. So here is your new problem. You are going to have the address of 192.168.100.0 using the CIDR notation /24, which I'll remind you is 255.255.255.0. Your goal is 5 new networks. So the question now will become, how many bits will you borrow to create 5 new networks? And after you do that, I want you to solve for the networks. So what are the new network addresses? What is the scope of each network? What is the new subnet mask and or CIDR of each network? And what is the broadcast of each network? And once you figure this out, guess we kind of lost the other values up here. So I'll tell you what we'll do. I'll copy this out, put this in a different window. All right, so let me bring this up. And what I'd like for you to do now is press pause on this video, and when you come back, I will go ahead and reveal the correct answer. Okay, so hopefully you took the time to work out this problem. Let's see how you did. So we know we started with 192.168.100.0/24. Our goal was to create 5 new subnets from our existing subnet. So the first question is, how many bits did we borrow? And if you came up with the answer of 3, then you were correct. We borrowed 3 bits to come up with our goal of 5. Now, before we move forward, notice that those bits borrowed gave us 8, but we only wanted 5. This is one of the problems with TCP/IP version 4 subnetting. Because of the way it was created, you cannot always borrow the exact number of bits to get the exact result that you're looking for. So in this case, if we had borrowed 2 bits, we would have only had 4 networks. Our goal was 5. So by borrowing 3 bits, we hit our goal of 5, but we've got 3 networks that we no longer want. Now that we have decided that our bits was 3, our new subnet mask is, okay, let's write this one out. Our new subnet mask is going to be a slash, we were at 24, we borrowed 3 bits, so slash 27. And in a decimal, that would look like 255, 255, 255, and the first 3 bits turned on would be adding up to 224. So that is our new subnet mask for each of the new networks that we created. So what are the new networks that we created? Well, we're going to be looking here at that 111 and these zeros to separate this out. So let's add in that and take a look at this one. So we're going to look at subnet mask 2. And what we have here are the new networks that we've created. So we have already identified our network bits as being in black and our host bits are being in purple. Recall that the host bits all have to have a value of 0 in the host portion when it is the network address. The network bits are going to change depending upon the position that you placed it in. So these are our networks, 0, 1, 1, 0, 1, 1, and so forth. And let's go ahead and add them out. So if our first network is 192.168.100, the first one is going to be 168.100.0. There's because all this adds to 0. The next one is going to be 192.168.100 dot, and that third bit turned on is 32. The next one, 192.168.100.64. And are you seeing the pattern? Remember this positional value right here, the one that last one borrowed, has a value in binary of 32. So every network is going to increment by 32. And if we do the binary math, that's exactly what we're going to find is going to add up. So let's go back here and finish this out. Our next one is going to be 192.168.100.92. 192.168.100.1. Oops, sorry about that. 100 dot. Sorry about that. Did you see my mistake? Did a little math adding wrong here. This should have been 96. All right. So this one now is going to be plus 32, which will be 128. That is the one that we're looking at right here. The next one is going to be 192.168.100.160. 192.168.100.192. And the last network address is 192.168.100.224. So if I come back over here and I bring this right next to it and make it a little bit bigger and maybe a little smaller. All right, so what we have here is this one is for here, this one is this one is this one's this, and that is the decimal representation here as well. All right, now we're going to do the same thing here, but this time we're going to compute the broadcast. So again, we look at this in binary and you convert it back to decimal. The first address is going to be 192.168.100.31 because these 5 numbers here will add up to 31. 1 plus 2 plus 4 plus 8 plus 16. The next one, 192.168.100.63. 192.168.100.95. 192.168.100.127. Now, I'm not a math brain here because if you look over here, all you have to do is pick the next number in the subnet and subtract 1 because my first network ends at 31 because the next one has to start at 32. So this scope has to be 231. So let's finish that out. 192.168.100.159. 192.168.100.191, and 192.168.100. And because this is the last one, all the bits are turned on. This will be .255. Oop, one extra 5 there. All right, so that represents our broadcast networks. So let's draw the same arrow here. So we know that this goes here. This is the broadcast for the second one, the third, the fourth, the fifth, sixth, and oh, I skipped one. Look at that. All right, we skipped the 127, 159. Which one did I skip? So I got there to 31, 32 to 63, 64 to 95, 96 to 127, 129 to 159, 191 to 55. Okay, so let's take a look at that again. Sorry about that. I missed, as you saw, the 223 because the next network here was 224. And the last one is just cut off a little bit on the screen. If I go back in here and I can scroll down, it would be the 255. Okay, so that is how we do a broadcast address. Then the scope would be the values that go from 0 to 31, but that's the entire scope. The usable scope then is the next number, which is 1 to 30. Those are the addresses that I can lease out again in a DHCP scope. This one would be 33 to, can't use 63, 62. This is going to be 65 to, can't use 95, so 94. This is going to be 97 to 126. Sorry about this. 129 to 158, 161 to 190, 193 to 222, and 224 is going to be 225. A little sloppy there. Try that again. 225 through 254. So this column right here is our usable scope. Our entire scope would be from this number here to this number here. But what we can actually use or lease or assign to devices on our network is what's in the usable range, the 1 to 30 and so forth through here. So hope you got that one correct. Sorry about that cutoff over there, but this is how you actually do some subnetting. All right, post any questions or comments. Thanks.